limits. If you pay attention, this is not hard. If you zone out and stare at your phone and don't listen to anything I say, it's very hard. So that's your choice, okay? Pay attention. It will be so much easier, okay?
I already have one of these.
Okay, set that up there. All right. The way this is read, this is saying the limit of f of x as x approaches a, and then do you guys see that's a teeny tiny little plus sign? You can see it on your paper better. Okay. That means from the right. So we're just going to write out what this means. Limit of f of x approaches a from the right. I'll show you what that means on the graph. We're just kind of going through what the terminology is. So the second one with the little teeny tiny negative sign, what do you think that means? From the left, okay. So I'm not going to rewrite all of that. I'm just going to write from the left. As x approaches a is just any number. Like you can see down here, 1 from the right, 3 from the left, 2 from the right, like it's just a number. Okay, then the last one, there's no little plus or minus. So that's just the limit of f of x as x approaches a. What you're doing on that is seeing if the left and the right match. And again, we'll go through that in the examples, and I promise that will make sense to you. Okay. Like if your limit from the left and your limit from the right are the same thing, then the limit is that number. Again, you'll see it in the examples. It'll make sense. All right, so let's look at the first one here. It says the limit of f of x as x approaches 3 from the right. So I'm going to go to an x value of 3, and I'm going to draw like a wall. Okay, so here's my wall. Not an asymptote at all. This is the wall. Okay. So as I'm approaching 3 from the right, and you have to know your right and left. Coming from the right, that means I'm starting over here on the right and walking towards the wall. Okay, so I'm going to draw a little guy here. Draw a little stick figure on your graph. And he is walking towards the wall. Okay, he's got to walk on the graph. He can't just float around anywhere. It's got to be on the graph. So as he gets closer and closer to that wall, what y value is he approaching? Okay, I heard lots of things. 3. What y value is my little guy getting close to? 3. You are done with number 1. Okay. All right, so number 2. Limit of f of x as x approaches 3 from the left. So I'm still looking at that same wall, but now do you guys see I'm coming from the other side? So I walk on the graph. He is walking towards 2, yes. The answer is the y value you're getting close to. Okay, so y values for answers. Are we okay with 1 and 2? Okay.
Why do we go to the left?
Because there's a little minus next to it.
So you wouldn't put a wall.
Oh, okay, got it. What?
You wouldn't put a wall at 3.
No, because it's approaching positive 3 from the left. Like, like here's negative 3 from the left. You see it? Yeah.
Does it matter that there's a hole?
No. You're walking up to the edge of the hole. You're not jumping through the hole. You're just approaching things, okay? All right. Now, guys, for number 3, this is what I'm talking about when there's no plus or minus. What I have to do is look at from the left and from the right. So I'm looking at my 2 guys. Are they going to run into each other? Like, are they going to be at the same level on the wall? No. So the answer to number 3 is the limit does not exist. Fan of Mean Girls in here.
Do I have to write
What?
You can write D-N-E.
D-N-E?
Does not exist, okay?
Yeah, can you give me the reference?
For Mean Girls?
Yeah.
You watch the clip at the end.
Okay, then.
Yeah.
I'll go look.
Why doesn't it exist? Look at the left and the right. Were they the same number? Like, did the two guys walk towards the same number?
No.
No, so the limit does not exist. It only exists if it's the exact same from both sides.
So the positive and negative, they're both y and different. It's just that what they both are would be just the same.
Yeah, we'll do more.
Would be like symmetrical.
You don't have to, you don't have to be complete. The graph doesn't have to be this symmetric. It can just be one thing down here,
A
one
line,
here.
right?
See a curve?
You said none, wouldn't that also be?
No, I will not take
Saying
none.
find the limit, when you're saying none.
You can write that, I will not give you one. So, it's up to you, your choice, always your choice, buddy. Right when I'm asking, or not. Okay, so let's try the next one together. Says as x approaches 1 from the right, so I'm drawing my wall at 1. I come from the right. What y value is my guy approaching? Okay. Number 5. 1 from the left. 0. So what do you think the answer to number 6 is? 0. Good. Okay. You will probably not have to draw the wall every time. You'll get to a point where you don't need little stick figures all over your graph, but if they help you draw them, okay? All right. Do you guys want to try through 17 on your own then? Okay, so try those. You can take a second to do that. How are we doing, guys?
Very well,
Very well. You like section 1?
so far.
Is this all it is?
Pretty much all of term 1.
Wow.
Yeah. See why we could maybe do more than one section in a day.
So done.
Okay, draw your gap. What's he walking towards? Does not have anything to do with what he's walking towards. Okay. So you just answered your own question. There. All right, guys, let's go through them. Some of you already done with the bottom too, that's fine. Okay. Same idea. Yes. All right, number 7. As x approaches 2 from the right. Everybody together. 1, okay. Number 8. 2 from the left. 1. Number 9.
1.
10 is -1.
0.
Good. 11, x approaches -2.
-1.
Good. -3 from the right.
0.
-3 from the left. 2.
Is that right?
2, yes. And as x approaches -3. Does not exist. All right. 0 from the right. 0 from the left. 0. Okay. How we doing? Any of those you want me to explain? 15, 16, 17. Here's 0. That's my wall. I come from the right. Where am I going? I come from the left. Where am I going? Are those the same?
Why is 16 negative?
It says equals. My equals got messy.
I knew it wasn't wrong.
Okay.
Also.
Okay? Yes.
13.
13. Negative 3 from the left. There's negative 3. If I come from the left. 2. Don't overthink these guys. Don't get weird with the holes and all that stuff. Just where are you walking to? Okay, try down at the bottom. I know some of you are done already, but I'll give you a minute here. And then we'll go over those.
Because we're doing all of those today, is that going to test this much closer?
No. Just means we have a lot of class time to practice stuff. Then you got them all?
I don't understand when you're done instructing someone.
Wait, what?
I said, Ben, you got them all.
I did.
Yeah, I don't understand when you're telling me the circles, like the whole thing.
What are you walking towards? You're not going to fall into the circle. What are you walking towards?
Do you say equals beginning or just beginning?
Either way is fine.
So if you're walking towards like from the right to the left, you have to start on like the top one. Like how do you know which circle?
Okay, so if I'm like walking to this and coming from the right, I'm not going to start over here. I'm going to start right here and walk towards it.
But how do you know which circle to use?
Because
Okay, walking towards what? Give me the example.
Like if you're walking towards that,
Towards negative 3?
towards -2,
Towards negative 2.
how would you know which one to?
Are you going from the right or from the left?
Well, like depending on if you're going right or left, how would you know which one to use? So like from the right.
Right or left, right? Right is over here. So from the right.
So okay, so it's whatever one is like the closest to. Like,
Yes?
If there's like a piece that's like closer to that side.
Well, this is, so if you draw a wall, you can only walk on the right side of the wall. You can only walk on the left side. Like from the left, you can't do this. It's not on the left side of the wall. Yeah?
Yeah.
Is that the part you're talking about? Do you know your right and left? I don't know right now. Okay. Very good. Oh. Don't overthink these ones. All right, guys. So 2 from the right. What'd you tell me? 2 from the left. Just 2. How many 2s do we need? Okay, 1 from the right. 1 from the left. And 1? Okay. Just approaches -1. Good. And just approaches -2? D and E, yes. Okay. How'd we do? Good. Questions? Anything?
jumps.
We're not doing that. Okay. We're done with 10-1. What'd you say, Vince? Or Vin? Sorry. Vince? What?
These.
Nope. We're not doing them.
Oh,
No calculator test, so we're not doing them right now. All right. We're okay with 10-1. All right. Flip all the way to 10-2. I know, look at that. It was like a 11-minute note section.
The one that's.
And 2. Okay. All right, looks kind of scary at the top, right? Like all sorts of
Yes, I can.
symbols, it's like hieroglyphics, right? It is not. These are just rules for evaluating limits algebraically. These are called their properties. We're going to use some of them. A lot of them are common sense, even though they look not so common sense here. Eric, put your phone away. All right, so the first one here, the constant rule, the limit of k as x approaches c equals k. That's just too many letters, right? Let's try it with numbers. Let's say the limit of 4 as x approaches 1. Okay. Limit of 4. Whatever's next to the limit is your equation. So we're really talking about the line y equals 4. If I graphed the line y equals 4, what does it look like? This way. So at 4, yeah, you're just warming up there, getting the arms stretched out so you can go this way, right? Yeah, okay. Yeah, that's good. Okay, so as x approaches 1, where's my y value? 4. As x approaches 82, where's my y value? 4. As x approaches negative 27, where's my y value? Okay, so when it is a constant here, that's what the k stands for. It just equals whatever that constant is. So this would just be the limit of 4 is 4. Okay? I'm not going to walk you through the rest of them. We're just going to use them in our examples. So come down. I'm cheating. Okay. Come down here. So the first one there. Limit of 3 as x approaches 1. What do you think?
I think it's
3. Good work, guys.
Thank you.
X approaches 1, always going to be 1.
No, it could be any number.
So what does that have to do with? What does that have to do with?
So that's what I was saying up here, like maybe the graph of this line. So like, what if it was as x approaches 20?
Oh, so okay, because it's
Yeah.
constant.
Yep, exactly. All right, so the next one, limit of x as x approaches negative 4. Okay, yeah, we could think about, okay, y equals to x, I know that graph. You're not going to want to graph all of these guys, okay? It's just not real fun. So all you really do, unless you have an issue with something being undefined, just plug in the x value into whatever you're finding the limit of. So if I plug the negative 4 in for the x, what do I get? Negative 4.
Oh, I see. And which rule is
And that was the identity one, yeah. All right, so number 3. Again, we could graph. That's a quadratic. Sure, I know what that looks like. I don't really want to graph it to try to figure out what's happening as x approaches 1. What can I do with the 1? Plug it in. What do I get?
7,
Good.
maybe.
That's it.
Wow.
Yeah.
I think that works.
So I just did 4 times 1 squared plus 3. Wherever there's an x, I put in a 1. You see it?
So easy.
It's so easy. Okay, let's look at number 4. Can I plug 1 in? 2 times 1 minus 1 over 1 cubed minus 2. So what's my numerator? 1. What's my denominator? Negative 1. So overall, that's just... Yeah. I like that. It's very satisfying. You feel good about this. What'd you say, Ben? Okay. All right, number 5. Plug the 0 in. What do you get? 2. Okay. All right, don't get scared of 6. Plug 0 in. So even if you forget what the cosine of 0 is, it's 0 squared times cosine of 0.
0.
Okay, yeah.
Wait. Cosine of
Yes.
1.
Cosine of 0 is 1. 1 times 0 is
So what's the cosine?
you can't do the cosine of just 1.
So then how would, if it was x plus
It
1?
might be as x approaches pi, or as x approaches pi.
So it probably wouldn't be 1.
Sorry. Probably wouldn't be pi.
Okay, you're good. Because I was about to say, like, I don't know how to do cosine of 1.
No, you're fine.
Okay.
All right, so far so good, guys? Okay. Ah,
Wait. Pi squared. What is pi squared?
pi squared is pi squared. What do you, like 3.14
What, is that what I have to do in my head?
Why are you doing that? It's not as x approaches pi though, it says x approaches 0.
But what if it doesn't say pi?
Then it's probably just gonna say cosine of x. It won't say x squared times cosine of x.
Just see, lots of times when I like in notes, it'll be like simple, and then on the test it'll give me like as x approaches pi, and I'm like, I don't know what to do with this.
You just plug it in, but that's not it. You would simplify that as, so cosine of pi would be -1
Yeah.
times pi squared. So you would just say negative pi squared. Like, that's all you do. Just plug it in. Okay. All right, guys, let's look at the top here. Try 1, 2, and 3 for me.
There's a pi in this way.
There's no pi. There is an e.
Oh.
I think you like pi more than you like e, but
It's in the natural logic.
E is very
it's e as in e representing a number, e.
So how much is this? Oh, this E equals
No, e does not exist.
E is equal to 2.7.
You don't need to know what e is equal to.
You just.
Don't overthink it.
We're just subbing them.
Oh, wait a second.
Oh, it's
Isn't e a constant?
it's 4.
Oh yeah.
Oh, it's just
It's just e, guys.
wait, why? Can you explain?
Okay, what? Remember when it was 3? Like if it said the limit of 3 is x approaches 4, what would you tell me?
Oh, okay.
Right, because it was just that constant. E is just a number.
Oh, yeah.
Terrible. I forget it.
Alright, do those 3 and we'll go through them here in just a second.
So, when is it? Identity is only with like.
What is it? You did, yeah.
I'm not sure what I was saying. I think I just,
You sounded really confident too, like, come on.
yeah, I was trying to show people up, but we all know it. It's taking out. Yeah.
All right, guys, the first one. Yes, you're plugging in a fraction. You can do it, I promise. 5 times 1/2 plus 7. So that's 5 halves plus 7. Could we make 7 14 halves?
I know you did it last name.
Right? Yes? What's 5 halves plus 14 halves? 19 halves, or 9.5, sure. Okay. We're fine with that one? Okay, plug a 4 into the next one. 3 times 4 over 4 minus 3. What'd you get? 12. And what do we get on 3? E. E is the number, guys. But it said the limit of pi as x approaches 4. That's just pi. Okay? It's a constant, so it is that number. Okay. All right, 12 and 13. Draw a graph of a function so that the limit does not exist at these particular values. So you have to sketch a graph. A graph. Doesn't have to be pretty. For the first one, the limit cannot exist at 1, 2, or 3. And then the second one, it cannot exist at -2, 0, or 2. I'll give you a minute to think about what that might look like. Think back to what we did in 10.1. When did the limit not exist? What? And the left and right didn't match, right? So,
Wait, could there be a hole? No.
The limit still exists if it's just a hole.
Or what if it's like a line with a hole? Yeah.
So that's just a hole, right? Yeah. Because you would approach the hole, like you'd approach that Y value.
Okay.
So, yeah. It's got to be a jump.
But it still has to be.
Go ahead.
Just jump from one.
Well, you need like a graph going on somewhere there.
Yeah.
You can't just be like, oh, there's no graph from x equals 1 to 3,
Is
so
there-
the limit must not
Does
exist.
there have to be anything at 2?
Yeah.
Here's, I would do something like this, guys. I don't know, maybe here, here, here.
Wait, do you literally just draw any?
Sure.
As long as it works.
So it just
Sort of library.
They also like to sort it. So that's to be a function.
Yeah, that's the word I was
It's not like square roots going one way and like half of probably going the other.
If I had, but like vertical line test, that's that, right? To be a function.
I guess not.
Hold it up.
Yeah.
So, when you have two different y values on the same x-axis, does one have to be an open circle, one has to be closed? It doesn't matter, like,
Doesn't matter which one's which.
so the starting one, like on the.
Yeah, that could definitely be. That's not matter at all. Guys, you can make it prettier. You can make it curves if you'd rather.
Curvy.
Like maybe, so this can't exist at -2.
But like, it can be basic though, right?
Mm-hmm.
Alright.
It's okay, Ella, we understand. I just want to limit right now.
Whatever you want, lines, curves, as long as it's a function, and as long as you've got basically a jump happening at every one of those places. Okay.
So,
You okay with those? Give it any more time. Okay. The next part is really applying these properties that were at the beginning. Yeah, these look daunting. They're not. Okay? What the properties allow you to do, you know the value of this limit and the value of this limit. You're essentially just going to be plugging those in because the limit tells you could take the limit of certain pieces and then evaluate them. So let's do the first couple together and then I'll let you try. So really what I'm looking at is the square root of 2 times what is the limit of f of x as x approaches c? Okay. Minus 4 times what is the limit of g of x? Okay. Okay. So I've got 4 plus 12. What's my answer, guys?
4.
4. Quite a bit less scary than you thought. Okay. Let's do 15 together. So what's the limit of f of x as x approaches c? So 2 plus 1 quantity cubed is what, 27? Okay. Squared, and then 1 more. All right, guys, so try the rest on this page, and then we'll go through them together. Guys, we're almost done with 10-2.
No, we're not.
Yeah. We're gonna do them all today.
Oh, really? The whole unit?
Yep.
That's cool.
We're doing all the notes, and then we can just practice the other days.
We're just doing 2. Oh, so you said 2 units.
Well, no, on Wednesday when we didn't do anything, I was like, well, we can do 10-1 and 10-2 on Friday. And then yesterday, in first period, everybody was there. I'm like, I'm just gonna do all 4 of them.
There's just 4.
There's only 4, and they all run
So
together.
10, 1, 10, 2, then 11.
No, then 10-3, 10-4. That's it.
But they're all short as well. 3 more.
Guys, you're still 55 minutes. You're fine. Yes, Ben. Yeah. When it's been on the calendar, since I gave you that calendar, you know the calendar I gave you has not changed. They've not moved the dates of the final. Yeah, I think 6th period. You guys are the first one, so it's even on the board back there.
Does everyone have to take it?
The final? No. If you have it, it is on the graduation day.
I'm graduating.
Yeah, I can't do it.
You graduated early. I'm getting it last year.
It's supposed to be a half day. They were debating at one point whether it was going to be or not, which I would be very sad if it's not.
Wait, the graduation.
We're not here
Yeah.
last day.
Wait, why wouldn't it be?
The county has to approve it.
Would we not take?
No, when it's a half day, it's like 2nd period for an hour, 4th period for an hour, 6th period final, go home.
Wait. Our finals the week before the final.
No. Well, they start that Friday, but then Monday, Tuesday, Wednesday are the rest of your finals, and then Thursday is
So
the
the
week.
final week is all of finals.
You guys are not in middle school anymore, where you're like, last week's the finals. Not where we are.
Why not? Just take the final and then different numbers.
No. Fine, you have to take the quarter test the day before that.
Oh,
Okay. Depends on if you take the quarter test. You don't take the quarter test, you get 2 full days of final. If you do, you get 0.
Are we gonna get like review topics?
Yes, I thought they were on the blackboard already, but if they're not, let me know. And they are.
what's the quarter test?
When is it?
Is it the retest?
Ted, you're killing me right now. This is
It's
not
oh,
new.
it's the retake, right?
The quarter test and the
Okay.
retake. All right, let's go through these. I don't know where we are right now.
I like them.
All right, did you get 1 for number 16? Yes.
Never.
Did you get a negative 12 for 17? Yeah.
The only thing
Did you get 0 for 18?
Yes.
And did you get 1 for 19? Yes. Okay. Any questions on 9-2?
No.
Okay. Flip in your packet till you find 9-3. Or 10-3, sorry.
Like, yeah.
What do you mean?
Like, if you didn't take any other, I mean, you do like basic addition subtraction, but like you didn't know,
You know no algebra?
yeah. Would you like be okay?
What if you
Oh.
be able to like put the patterns there?
If you don't know how to solve an equation, how are you going to do any of this stuff? If you don't know how to exponent rules, how to combine like terms, how to graph anything.
Science character.
All right, guys, 10-3.
Dude, yeah, the science experiments we have.
All right, guys, jot down these 2 right here. Limit as x approaches 0, sine of x over x is 1. And limit as x approaches 0 of 1 minus cosine x over x is 0. Guys, these are not ones you can evaluate algebraically. You need to know these, though. You may have to use these as substitutions in certain problems. So these 2, file those away in your brain, okay?
Uh-oh. My brain's
It's only when x approaches 0, yes. Do you guys understand why we can't plug in the value and figure it out? What happens if I put a 0 in right here? Yeah, problem, right? Okay, so that's what 10-3 is all about. if you end up with 0 over 0, or in any way 0 in the denominator, you should think, oh no, I can't do that, okay? Gotta do something else. That's what 10-3 is about.
Oh, can we just talk about this? Can we just talk about what she just did?
Totally works, right? Okay, so you have some strategies. We're actually skipping number 1. It's not as bad as it looks, but it's easier to see what we're doing in number 2. So let's look at 2. Your first strategy is always just try to plug it in. So that's what we were just doing so long ago in 10.2, okay?
Wait, it's free.
That was forever ago, yeah. A month ago, according to Riley, so. All right, can I just plug 3 in?
No.
No problem, right?
Oh, no.
3.
Oh no. Okay. So we need to try something. So I'm gonna do limit as x approaches 3. What do I say never goes away? Factor A. Yes. Can we factor that numerator?
I hope not.
Yeah, nope. Impossible.
X minus 3, X minus 3.
No, it's impossible.
Well, X minus 3, X
It's possible.
There we go. Over x minus 3, right? Do you guys notice how I wrote the limit statement again too?
Yeah,
That notation matters. Start getting used to that.
cancel it out too.
All right, so get rid of your x minus 3s, right? Could I plug in my 3 now? Yes. That would be a hole. We're essentially finding the y coordinate of the hole. So what do I get? All right, you've done with it too.
Oh, so you
Wow.
got 3 plus 2.
Okay. Graphically, guys, that's this line, x plus 2. Only when you get close to 3, there's a hole. So the limit, you're approaching it from both sides, is 5. Okay. All right. Try number 3 for me. And let me guess, you need a reminder of how to factor cubes.
No.
Yes.
I do.
So, I'm confused about the, wait, about the last one with 5.
Okay.
Well, I just like
Ask
my
away.
where you got that.
So you got the canceling out, right?
Yeah.
Okay, so now I'm asking you the limit as x approaches 3 of x plus 2. What would you do?
Oh, then you took 3 and put 2.
Yep.
Or,
For x, yeah. I knew what you meant.
wait,
All right, guys, try to factor it. It's up there. This is the
You didn't explain how to do
It's the opposite.
cubes. There you go.
I'm gonna opt out.
No, you can't opt out. This is not an AP exam. It's factoring.
Yeah. What, if you just like,
So what's the cube root of x cubed? Okay, that's what A is. What's the cube root of 1? 1. That's what B is. So now fill it out. Yeah, like, okay, I found A is x and B is 1. Go.
That makes me nervous.
Makes you nervous. What'd you say? No.
No. Oh, because I know what I did. I'm just.
Did you do like x squared is 2 or something and then subtract?
No, I canceled out my x minus 1, but I still fit into the equation.
Oh, okay. So you get
Yeah.
0 times it, yeah.
Yeah.
no, I'm just saying.
Then. Okay, so we're not on question 4 yet. So hold on. All right, guys, are we okay with the factoring on 3?
If the answer is
The answer is 3, yes. Cancel that out. 3 is your answer after you plug it in.
It was the first one yet.
4's maybe what you're gonna think is the hardest. I don't know. You might think 6 is the hardest. But it's not really. There's nothing that I'm like.
It was a joke.
Oh, okay.
That being the hardest one is like weird.
Okay, good. I thought you were like really worried.
Feel a little bit.
A little bit worried, okay. All right, so let's look at 4. There might be one or two of you that sees the factoring in this. You're definitely not going to see it in number 5. So what we need to practice when there's a square root is multiplying by the conjugate. Okay? Like a dance line. Full of shapes today, guys. Okay, conjugate. You look at the square root part of your fraction. You guys are used to seeing it in the denominator. It's not always going to be in the denominator for what we're doing. Remember when you rationalized, you dealt with a conjugate? So I look at that and I see square root of x minus 2. I'm going to multiply by square root of x plus 2. Okay. All I did was change the sign and start with the square root. Okay, don't go nuts multiplying. Just wait. Easy, okay? So, limit as x approaches 4. All right, I am going to multiply out the 2 that are actually conjugates of each other. The other part I'm leaving alone. So in this case, the numerator, I'm just going to leave as x minus 4 times the square root of x plus 2. What do I get in the denominator when I multiply that out? 2z x minus 4. Do we understand how the multiplying works with those two, or do you want me to write it all out? Square root of x times square root of x, that's just x, right? Then I'd have plus 2 square root of x minus 2 square root of x. That's the whole point of the conjugate, is to get those middle 2 to cancel out when you multiply.
4.
And then negative 2 times 2 is negative 4. Okay, what do you see then? Yeah, okay, we can get rid of these. Gone. Could I plug in a 4 now?
Still away the square root sign.
Well, a square root of x times the square root of x, like what that is the square root of x squared.
Okay. So.
Like if you had square root of 3 times square root of 3.
It must look like negative 2 times negative 2.
Yes, which is 4.
That's 4, but we don't take the square root of that.
It's not square root of 2 times square root of 2. Okay, let me. So I have more room. Okay. Square root of x times square root of x. X, right? Okay.
Oh, it didn't go all the way across.
Right.
Oh.
Oh, well, that's easy. Okay, we're good.
Yeah, I thought it went all the way across. I was like, ah.
Gotcha now. Okay, so when I plug in the 4, what do I get now? 4. Okay. The answer is 4, because square root of 4 is 2, 2 plus 2 is 4. Okay, I want you guys to try 5. It's the same idea. But do you guys see how the numerator's where the square root is? Still are going to do the same approach. Do you need help with starting it? Oh, okay. You guys are way too nervous about that today.
Nervous or just?
Okay, so it's going to be square root of x plus 1 plus 1. That's what's going for both your numerator and denominator. What? It's not going to be a problem. I promise. I know, it looks like we just undid any sort of rationalizing. But which ones do I actually multiply together now? Only do homework 10-1 next time, okay?
Okay, wait, just do 10 4.
10-1.
Oh,
Homework.
10 1. Okay.
Yep, it'll take you like 5. Okay.
Thank you.
Yep.
We do the top.
Yes. So when I multiply that out, what do I get? Yeah, because it's really x plus 1 minus 1, right? I'm going to do it in a couple steps just to make sure everybody sees all of it. So I have x over x times square root of x plus 1 plus 1. What happens? X's are gone. Now, what's left in the numerator, even though I canceled everything out? A 1. It's a 1. You got to remember what's in the denominator. Still in the denominator of your fraction, okay? You can't just have blank space fraction bar denominator. There's something up there, okay? All right, and now can I plug in the 0? Yeah. What's the 0 plus 1? Square root of 1 plus 1. So I get 1/2. That is your answer.
I feel comfortable with that.
You feel comfortable with that?
Uncomfortable.
Uncomfortable with that. Okay.
See a radical on the
Nervous still? A little nervous?
bottom? Like when you try to put a radical on the bottom.
No, that just feels wrong. Like, let me put this down here. Yeah, it's okay. But see, it's not there in the end. No, we're gonna do number 6. Ava, you look like you have a question.
The reason there's no one in here because the slash.
Yeah, if I had 3 over 6, that doesn't equal,
Yeah.
right? Okay. All right, 6. We're gonna do this together because you just won't see it without my help. I don't think. So, all right, limit as x approaches 0. I can't plug the 0 in right away because I have undefined. What is tangent? Yes, good. You remembered things. All right, sine of x over cosine of x. Now it's divided by x. Do you guys understand that that is the same as me saying times 1 over x?
Yes.
Are we uncomfortable or comfortable with that? Okay, we're nervous, okay. A little bit uncomfortable. Are you okay, guys?
What was the last? Oh, okay.
What, someone said? Oh, I have no idea. You're welcome to come home. They're not a scary bunch. Somebody. All right, sorry about that. Okay, now look, this step to this step. How uncomfortable and nervous are you now?
Yeah, that's true.
Look, guys. Just moving stuff around, right? Multiplication. 2 times 3, 3 times 2.
Just do that. That's like sacrilegious in that.
It's totally okay. You're uncomfortable now. Think about it, if you multiply straight across, we would have sine of x over x cosine of x. Sine of x over x cosine of x. They are equivalent, I promise. Okay, let me write out the next step. Hey guys, you gotta stay with me. I know, I'm sorry, I'm writing more than you really want to. Okay, this is just me doing a property. I can really think of it as 2 separate limits. Okay, this guy.
Switch the X.
Does that look like something you're supposed to
Yeah, that
have?
was like 1.
Ah, yeah, like doesn't that look like, right? Okay. So that guy's just 1 times, okay, you have to know what the cosine of 0 is when I plug it in. It is 1, so what's 1 over 1? 1. And what is 1 times 1?
1.
Okay.
So it's just guess 1.
It went down to 1. Does that make sense to you? I know you don't like all the moving and manipulating of things there, but. Okay. Limit of sine of x over x as x approaches 0 is this 1.
Yeah.
If I plug 0 in over here, this is 1. And 1 times 1 is 1.
Put 0 for X. Would that just be 1 over 0?
Now, what's the cosine of 0? we're doing a few of these, but not all of them. Yes.
Number 5 on the other one.
Yeah.
Like I
know what it is.
Multiplied by the conjugate, but when I looked at that, I would think to like, since I would only think if it was literally bonding. Like I know you said.
Yeah, anytime you see a square root in the numerator or denominator and you can't just plug it in, thanks, conjugate. Yeah, I know, it's weird. You're like, I'm undoing like the way it's supposed to be written, but that's just how it works. Okay, turn the page. We've got some multiple choice and weird looking ones, but they're not that bad. All right, number 7. So limit of f of x as x approaches 3. Guys, stay with me here. We're close. We're not. This is 10-3, the end of 10-3. Flip.
That's okay.
10-4. We'll do like stand up and stretch after 10-3, okay? All right. So number 7. That's a piecewise function.
No.
Okay. We did those last unit. Do you really want to graph it? No, I didn't think so. Let's think about limits. Remember, the limit didn't exist when we had a jump, right? But if the two pieces run into each other, doesn't the limit exist? Okay, so we just need to figure out these two pieces. Do they meet, or is there a gap? So plug it in. So plug 3 into the first one. What do I get? 9. Plug 3 into the second one. What do I get? 14, right? Are 9 and 14 the same number?
No.
No. So we have 2 different y values happening. So what do you want to
D
do?
and E.
Okay.
Well, DNA.
There we go.
Wait, don't forget about your flip.
I know. Yes. Thank you. Good reminder. I'll make sure we have time for it. Okay. Number 8. So this one, it's just asking you about f plus g, and all I give you is these 2 graphs. Eric, bring your phone up, put it in the holder.
They have DNA.
Okay, as x approaches 2 for f of x. First of all, does this dot matter at all when I'm talking limits?
No.
No, it means nothing to you with limits. Function value, yes. Limits, no. So what is the limit of f of x as x approaches 2? 1 plus, what is the limit of g of x as x approaches 2? 3. It's asking me to add those together, so I get
4.
Good job, you guys can add. And you're done. So it looks weird with the graphs, but all you're doing is adding the y values. Okay? All right, we okay with that one? All right, number 9, what do you think we're going to have to do? Figure it out. Yep, figure it out. It's a piecewise function. I want to know if the limit as x approaches 4 exists. So what should I do with 4? Plug it in. What do I get in the top one? 0. What do I get in the bottom one? Oh, what do you think? Yeah, you can say yes. Sure. If you really wanted to, you could tell me the limit of f of x as x approaches 4 is 0. But the question only asks, does it exist? So yes, really is the required answer.
You answered another way.
All right, not a lot of work to show on these. A lot of these are you get it or you don't. I mean, there's not a lot of partial credit in this unit. So, okay, 10. These numbers over here are just talking about an AP Calc exam. Don't be scared. Yeah, an old AP Calc exam. Yeah, getting there, guys. Okay, so the limit as x approaches 0. Guys, it says of f of x minus f of 0. Well, do I know what f of x is?
No.
Yes.
Yeah.
You do.
Yes. What is it?
0x squared.
2x squared plus 1. Okay. Minus f of 0. Could I find f of 0? Yeah, what would it be?
1.
1.
Wait, what?
Over x squared. Why is that 1? So, f of 0. If I did f of 0, that means 2 times 0 plus 1. Yeah, just plug it in. Okay. So that was like instant yawning. That's not good. Yeah. Stretching is coming in like 2 minutes. Yeah. Because we're skipping a couple. Okay, so I have 2x squared over x squared. What happens? Okay, so it's the limit as x approaches 0 of 2. It's a constant, so it's just 2. That's it. Okay. All right. We're skipping 11 and 12. Did anybody have questions on 10 before I move on? Yes.
It didn't say limit is x approaches 0. Maybe it's to do with something else.
Like if it was a different x value, or
If it was like x approaches 1.
it. So no matter what x approaches, if this is just a constant, it's always that constant. Okay. I mean, you could have like plugged it in, but it would all cancel out anyway, and leave you with just a 2.
Wait, what is? What's 0 squared?
What?
0 squared.
0.
0? Why is it not?
These cancel. We had 2x squared.
Oh, because it's negative 1 to minus 1.
So then I'm doing the limit as x
That's
approaches
like
0.
that's like 4 divided by 2.
Yes. Okay, let's go to
There's nothing.
a 1.
1.
Yeah. All right, 13. Last one for 10-3. Guys, we've moved up to 1998 now. We're not smarter than 1998. How are you smarter than a year? I don't understand.
Smarter as smart as 1988 maybe.
Well, you haven't gotten the question right yet.
It is close.
No, we're gonna do it together. Okay, let's leave the numerator alone, and let's factor the denominator.
Can we just put A for X?
You could, and you would get 0 in the denominator. So, oh no,
That's not fun.
don't do it. What does that denominator factor into?
X squared minus A squared or plus.
Both, yes. X squared minus a squared, x squared plus a squared. So what happens?
Cancel that again.
Yeah.
You get 1. Don't forget the 1 in the
Yeah, you
numerator.
need that 1. Then I can plug in A, and what would I get?
Wait, how do you know what A is?
It says as x approaches A. So instead of the x, I'm putting in the A. The answer is B. Yes. So really, it's we're talking X's and A's, and we hear random B.
What did you get? What is it? Answer is B. Well, actually,
Ah. Hmm? Okay, were you okay to here? Okay. X is approaching A, so instead of X, what do I put in? A. So instead of X squared, it's going to be A squared. And how many A squareds do I have?
It's B.
Okay. All right. Take a break for a second. Stand up if you need to. And 4.
Alright, give me like 2 minutes.
Here, have a packet. Have fun. Be terrible.
Do you have
Mm-hmm.
enjoy your weekend?
Mm-hmm.
And like, because I had tests this week, I like neglected all of my homework, so I have all of it next to on Monday.
Oh, dear.
But most of the final project, isn't there a final project in English? It's the answer. But that's it? My teacher never said, my teacher never said it was the final project. I completely just really random with it. I put baboons in there as much as I could. Because the students, they did South Africa and they were like invaded by the British. I like put that as much. Yeah, I figured. Yeah, did you hear that? do on Monday.
This noise class is really good.
It's cold.
Like, I like the
So we're
cold.
doing another.
Yeah. Usually it's cold in here. and It's not today.
It's oddly humid.
Yeah.
We have a phone
It's like
call
room
today.
temperature, so it's tolerable, but like I need hotter and I find it.
I really
No.
want to.
And if it's like hot next week, it'll be unpleasant.
Sure.
Okay. Round up the troops.
Alright.
Go get them. Help them to come back.
I'll check in more.
What? No. Why are they on the other way? All right, guys. Are we ready for 10-4? I think 10-4 is easier than 10-3. We're just starting. I don't know where everybody else went.
I thought we're in more.
Okay, I didn't really think they would be. So.
I was.
All right, guys, we're starting. Everyone will catch up, I think. All right, we're doing infinite limits.
Infinite limits.
Infinite, like we're dealing with infinity. Yes.
So some
Go back to the normal schedule.
not next week.
When did we go back?
Like the normal.
You have 2 days of that left for the rest of the year.
Really?
May 24th and May 28th.
But why?
Because there's no testing that day. Every other day there is some sort of SOL, senior exams, convocation, who knows, everything going on. So,
That's pretty cool.
all right, guys. Jot down the first one. We are doing infinite limits. What do you notice in my limit problem? To infinity and beyond, yes. Toy Story clips in, and just
Everything is.
yes, it's a great unit.
Don't come high.
What? It does. Mark's cute.
You know, I just don't like Bo. What? Yeah. It's just like not like evil, but like very like. I like her. I know.
Okay, guys, let's talk about what this means. All right, guys, so infinite limits. We're talking about going to the ends of your graph, either to positive infinity or negative infinity. Didn't we just do that with end behavior in our last two days?
That's exactly what I was thinking actually. I was like,
Yes, it's the exact same idea. So, okay. All right, so the whole top heavy, bottom heavy equal, that is still what we're thinking about. So what is this as far as top heavy, bottom heavy? Bottom heavy. What was our horizontal asymptote then?
Oh.
Or just what do you think about when you think bottom heavy? What does that mean? Big on bottom.
We teach last year, like a couple of things.
I know. Yeah. So that's the issue. All right, bigger on the bottom, guys. If it is bottom heavy, that's approaching 0. Okay? So that means if I go way out to the ends of this graph, it's going to equal 0. Okay, so that is called
And that's the
bottom heavy. So limit as x approaches infinity or negative infinity should equal 0. Okay, so let's look, what if the limit as x approaches infinity of 4x squared minus 3 over 5x squared plus 1. Top heavy, bottom heavy, or equal?
Equal.
Okay, when they are equal, remember what we did?
Divide the coefficients.
Yes, so what would this equal? No, you don't have to do synthetic division. No. You just look and go, okay, these.
I was like,
Yeah, no. It was.
that was this year?
We did it last year too.
Oh.
You look at those, if I divide them, The x squareds would cancel, right? And what are the coefficients? Okay, that's your limit. So when they are equal, you divide leading coefficients.
Why is it 4 minus 3, 5?
What? Why is what?
Why is it 4 minus 3, 5 plus 4? So,
Okay, you can't cancel the x squareds out of the entire, like there's a minus sign in there, like 4x squared minus 3 over 5x squared plus 1. You can't go like that and say, cool, that's 1/6. No. Like, we are only looking at this part of it. Like, if that's my fraction, I can reduce that fraction to just 4/5. Okay? And the reason that we can think of it that way, guys, you're looking as x approaches infinity. Are a 1 and a 3 really important when we're talking about numbers as big as infinity? No, they don't matter. This number is humongous, this number is humongous, okay? 1 and 3 don't really matter, so they're insignificant. Okay, so we clearly need a top-heavy one now. Yeah, we do. Whoops, not x squared, sorry. Wow, okay. Did I say 3x squared plus 5? Okay. There we go. All right, top heavy, right? You're going to start the same way we did with the last one. Okay. So you're going to divide leading coefficient. Well, you're going to divide most important terms, whatever you want to call them. So you're dividing a little bit, and then you're looking at what's left. So if I have 3x squared over x, what does that simplify to? 3x. Okay. Do you know what that looks like? No, you know. If I asked you the line y equals 3x, graphic, what would you do? Yeah. Does it have to be a perfect graph? No. We're looking for like general direction this is going. So there we go. So as x approaches infinity, where is this going? Infinity. That's your answer, okay? Now technically, is infinity a defined value? No. So with that, we're going to say does not exist. You're going to say, hey, it's headed this direction, but I know that's not really a number, so we're going to include does not exist. So you divide and then think about graphs. Okay.
That's it.
Those are the 3 scenarios. Yes.
Will top heavy always be infinity equal?
Or negative infinity.
Okay, so
So it'll always be an
But you have to tell me direction. You have to get that part right. So let's try a couple. All right, let me write 4 of them for you.
Are all of them?
Mm-hmm.
This has been going on for a while.
The last one will make the limit as x approaches negative infinity. Okay. Okay. Try this one. No, x to the 5th minus 1. 5x to the 4th over x to the 5th minus 1.
So it's both equal, right?
X to the 4th and x to the 5th are not equal.
Oh, I just thought, not gonna lie,
Do you always have to draw the graph?
If it is top heavy,
Yeah, so like, what'd you say?
like just a sketch, not like,
Okay.
you have to know, like, just kind of gotta know like where it's going.
Okay.
Yeah. Yep. I mean, it's a lot like end behavior in the last unit, like odd and positive, odd and negative. You know, that's even positive, even negative, that stuff.
You have to keep the notation of like unit, like, you can just write number.
You can just kind of like do what you need to do off to the side, and then equals, it should be a number or infinity or negative infinity, you know, whatever it is. David, you got him?
Yeah,
You have these 4 done?
Nope. I got the next one.
These are the nodes, try them.
No.
Grunting no, it's not gonna help.
No, we're into the first 4 problems. No, these are first 3 problems.
Yeah, and said, here's 4 examples, try. And you said, oh, head on my desk?
David, yes. I don't want that. Then I don't function.
I have you for 10 minutes. Do this. Do these so I can show you the clip.
I lost my pencil.
Oh, goodness. Life is hard. It's under you.
Oh,
This is gonna be a good video, guys.
Oh my God. Yo.
It's okay, David. You're forgiven.
I just don't even remember this class.
Oh no, it's not good.
Wait, no, you just exposed me.
I know. What'd you get? She had to leave for districts, I think? She had a reason. She took this for me. All right, let's look. David, you can join us as we go through them. Okay.
Never mind, Jesus.
Oh,
I asked you this, like, 20 minutes
I
ago.
remember.
All right, Ben, phone away.
And I'm talking about my teacher.
About your teacher. That's not really what I want.
Teacher.
Oh, he's doing an evaluation, like one of those,
Yeah, no, it's not the time. Not a way away.
bad noise.
That was kind of crunchy. Yeah. All right, number 4. Top heavy, bottom heavy, or equal? Equal. So what's your answer? Okay. Number 5. Top heavy, bottom heavy, or equal? What's your answer?
0.
All right. Whew. We like 4 and 5, right? Okay, 6. Top heavy, right? Okay, so let me.
Negative 2x.
So negative 2x squared. So I go, okay, that's this guy. Right? Okay, and what do we need to include with our negative infinity? Good. All right, how do we feel about 6?
Is that's an is, right?
And is, I don't know what that means.
What is it say?
Negative infinity dne.
Oh, did it?
Okay. All right, number 7, top heavy again, right?
That looks like a lot.
Yeah, I'm like,
Does not. It says.
It looks like dicks.
Oh, what a day, guys. Just gonna keep graphing. All right, that's what that one looks like, right?
How?
All right, guys. That's x versus negative infinity. Where's it going? Where are we going? Positive infinity or negative infinity? Which one? No, yes. X is approaching negative infinity. I am going this way. Where's the graph going? Yeah, and apparently I need to be careful with my D and E.
Yeah.
D and E. Okay. All right. Questions, guys. Wait, there's a lot of questions.
Half right infinity, or maybe that's what we're like top heavy.
Yes. I mean, you have to tell me the direction, and then it doesn't. Okay. All right. So guys, there's a couple of other things that we'll fill in with like some warm-ups and some practice, but that's like 90% of the notes.
So we have
Okay.
1 or 2 classes for
Well, we have, let's see, today's Friday, right?
Yeah.
So we have Tuesday, Wednesday, and the following Tuesday to practice all of these things, and
So we have 3 days.
one of them is like, the last one is definitely review, but all the others are just reviewing and practicing, so kind of. And you'll have some homework too each day.
I have an announcement real quick, class. Today is Sophia Crawford's last day with us. Calfer.
That one.
Sophia California's last day in our class.
Okay.
And you guys should all say thank you to her for a great year. And doing this class, thank you.
Lovely.